This is Mr. Martin. These are video notes for Pre-Calculus Advanced. We're in Unit 9. I know this says 5, but we're in Unit 9. And we're continuing talking about vectors. We're going to be talking about dot product, angle between two vectors, and we're going to look at an example of work. Starting with dot product, in the video we're going to learn actually how to calculate this, and then we'll continue our discussion in class about what the dot product actually means. It's a strange concept, but you'll use it in physics. Again, we'll just learn how to calculate the dot product in the video. So if we have two vectors, vector v, which is ai plus bj, and w, which is a2i plus b2j, then the dot product v dot w, notice we say this v dot w, that's how we say that. It's not really multiplication. It's kind of a new operation that combines addition and multiplication. It's defined as a1 times a2 plus b1 times b2. So we're multiplying the two x components, and we're multiplying the two y components, and then we're just adding those up together. So if you'll notice, what we end up with here is a scalar quantity. It has no associated direction. We take two vectors, we calculate the dot product, and we end up with a scalar quantity. So if you want to take a look at this first example and give these a try, based on the formula up above, feel free to pause the video and try those. Otherwise, I'm going to work through these, and if you do try them, you can follow along and check your answers afterwards. Okay, so the first thing that I'm going to do, because I personally prefer to work in component form, so I'm going to just change this to 2, -3, and I'm going to change this to 5, 3. All right, now since we're doing v dot w, so again, the formula is to multiply the x components, so I have 2 times 5, and I'm going to multiply the y components, so that's -3 times 3, and then we just simply add those up. So we get 10 minus 9, which is equal to 1. So the dot product of these two vectors is the scalar quantity 1. All right, again, anytime you feel like you got the hang of this and you want to pause the video, and then you can restart it to check your answers, feel free to do that. So now we're going to do v dot v. We're going to do the vector dot product with itself. So now we're going to have 2 times 2, because that's the x component of v times the x component of v, and -3 times -3, that's the y component of v multiplied by itself, and then we'll just simply add those up. So we get 4 plus 9, or 13. All right, now let's try w dot w. So that's going to be 5 times 5 plus 3 times 3, or 25 plus 9, which is 34. All right, now these last two examples are kind of special cases here. So let's go ahead and let's find the magnitude of v. So we know the magnitude of v is going to be the square root of the sum of the square of the two components. So that's going to be 2 squared plus -3 squared. So that's going to be the square root of 4 plus 9, which is the square root of 13. Okay, so we can see that when we do v dot v, we got 13. When we find the magnitude of v, we get the square root of 13. So really, I could find the magnitude of a vector by doing its dot product with itself and then taking the square root. So something to keep in mind. As always, if you have questions about these, make sure that you ask. All right, moving on to angle between two vectors. So if u and v are two non-zero vectors, then the angle theta, we're going to measure this angle between 0 and pi, between u and v, is determined by the following formula. So we've got that the cosine of theta is u dot v, so here's an application of dot product, over the product of the magnitude of u times the magnitude of v. Alright, so when we're finding angle between vector, we've got three things that we need to find. We need to find the dot product, and we need to find the magnitude of one of the vectors, and we need to find the magnitude of the other vector. Okay, and then at the end, don't forget, in order to solve for theta, we're going to have to take the cosine inverse of both sides. So there are other ways you could find the angle between two vectors. You could find the angle that each of them forms with the positive x-axis and then subtract it. This is going to be a much easier way. If you feel like you want to try these examples again, please go ahead and pause the video. Otherwise, I'm going to go through these with you. So I'm just going to draw a little sketch because this helps me visualize what's going on. So I have 4, -3. So here's the first vector. And then I have 2, 5. So here's 2, 5. And when I talk about the angle between the two vectors, what I'm talking about is finding this angle here. Okay, so we always want to find the angle that's going to be less than 180, or between 0 and 180. Again, if we go back to our definition here, between 0 and pi, between 0 and 180. Alright, so our formula says that the cosine of theta, we're going to call this theta here, is going to be u dot v divided by the product of the magnitude of u times the magnitude of v. Alright, so I've got u dot v. I'm going to do some calculations on the side. Again, I'm going to multiply the x components, so that's 4 times 2. I'm going to multiply the y components, -3 times 5, and then I'm going to add those. So I get 8 minus 15, so the dot product of these is -7, and then I need the magnitude of u, so that's going to be the square root of 4 squared plus -3 squared, which is the square root of 16 plus 9, that's 25, and the square root of 25 is 5. And I also need the magnitude of v, so that's going to be the square root of 2 squared plus 5 squared, so that's the square root of 4 plus 25, which is the square root of 29. Alright, so now that I have all of this, I can substitute it into my formula, and I'm going to take the cosine inverse of both sides as well. So I know that theta is going to be the cosine inverse of u dot v was -7, and the magnitude of u was 5, and the magnitude of v was square root of 29. And if I substitute all this into our calculator, we're going to find the answer in degrees. So we'll find that, make sure your calculator's in degree mode, then we will end up with 105.1 degrees. Alright, so why don't you go ahead and pause the video and see what you can do on the next example here, and then when you restart the video, I'll have the solution there for you, and you can double check and see what you did if you didn't get it right. Actually, you can go ahead and do the next two examples. So pause the video now and try these examples, and then you can check them when you're done. Alright, so if you pause the video and work this out, you should have gotten 150.7 degrees. So here's a little sketch. You can see this angle looks like it could be about 150 degrees. So the dot product of u and v would be -41, and then the magnitude of u is square root of 34, and the square root of v is square root of 65. If these did simplify, really there's no reason to simplify them, because we're going to be plugging it into this calculation here. So it's easier just to leave them as unsimplified radicals. And then when you calculate this all out, you should get 150.7. Again, make sure you ask questions if you have them. Now, for this one, this is an interesting case because when we did u dot v, we get 0. So I've calculated the magnitude of u and v, but we really don't have to because we're going to end up with u dot v, which is 0 over some number. So 0 over some number is just 0. And we know that the cosine inverse of 0, meaning what angle between 0 and pi has a cosine of 0, well, that's up at the top at pi over 2 or 90. So what this means is these two vectors, are perpendicular. All right, and this is an important concept that we have, and we're going to have a word for this perpendicular. When two vectors are perpendicular, we say the vectors are orthogonal. Okay, so here's another vocabulary word. So if I give you a problem and it says determine if the vectors are orthogonal, you want to see if they are perpendicular. If they're perpendicular, their dot product is going to be 0. Okay, so keep that in mind. New concept here in this example, another vocabulary word. Again, if you have questions, make sure you ask. And let's move on to this last example here. It says a Boeing 737 aircraft maintains a constant airspeed of 500 miles per hour in the direction due south, which means directly south. So for this direction here, if we're thinking about this on a coordinate grid, this would be negative 90 degrees. Okay, the velocity of the jet stream is 80 miles per hour in a northeasterly direction. Okay, so for this one, we could think of this, it's north and east, so this would be 45 degrees. Find the actual speed and direction of the aircraft relative to the ground. So I'm going to draw a little picture here. And I've got the airplane is going directly south at 500. And the wind is blowing at 80 miles per hour at 45 degrees. And we want to find the actual speed and direction. So why don't you go ahead and give this a try. This is kind of review from the last section. So you should be able to do this. Basically, we're finding the resultant velocity and direction, which you should be able to do. So pause the video, and I will have a solution for you at the beginning of the next video so you can check. So we'll see you there.